Hi students, today I am going to introduce the basic concepts and basics of Fourier series. Actually, Fourier series is a series in which a function can be written as, a function f of x can be written as series which contains sine and cos terms. We can able to write any function in this form if f of x satisfies certain conditions. That is, we call those conditions. Actually, this is named after Joseph Fourier. This is named after physicist Joseph Fourier. Okay. If f of x satisfies certain conditions, means the following condition. First one is f of x is, before going for this Fourier series definition, I want to define some basic definition. What is that? F of x is said to be a periodic function. Is said to be periodic function with period t. If f of x plus t is equal to f of x. If f of x satisfies this condition, we say that that function is periodic function. The best known example for periodic functions are sin x, cos x, etc. That is sin x, cos x, tan x are periodic functions. Periodic functions with period 2. Apart from this definition, I want to define one more definition. A function f of x is said to be a real valued function. Actually, we are discussing about real valued functions. A real valued function, f of x is said to be even function is said to be an even function if it satisfies, if f of minus 6 is equal to f of x, even if you are getting f of minus x, if you replace x by minus x, then also the value of the function remains same. We say that it is a periodic function. Sorry, it is said to be an even function. Is it okay? Now, you consider this example. If f of x is equal to x square, then even if you replace your x by minus x, you will get minus x whole square. Minus x whole square is x square itself. X square is nothing but your f of x. Therefore, f of minus x is equal to f of x. Therefore, your f of x is said to be, that is x square, is an even function. Therefore, f of x is an even function. Okay? A real valued function, f of x is said to be if f of minus x is equal to minus f of x. If you replace x by minus x, a minus sign is attached to f of x, then we say that it is an odd function. If you consider an example like this, your f of my x is equal to x cube like this. If we define a function like this on the for all real values of x, then f of minus x is equal to minus x whole cube, which is equal to minus into x cube. It is minus into x cube can be replaced by f of x. Thus, we are coming across the conclusion that f of minus x is equal to minus f of x. Therefore, f of x is equal to x cube is an odd function. Okay. We know these things. We define this periodic function. We know this even function, and we know this odd function definition also. Just I am recalling those things. Okay. Now, I came to the basics of that Fourier series now. If a function f of x satisfies the following conditions, which are called as Dirichlet's condition. What are those Dirichlet's conditions? Consider a real valued function. Consider a real valued function f of x, which satisfies the following conditions. Condition. What are those conditions? First one is f of x is periodic function of period 2l in the interval a comma a plus 2l. First one. Second one is f of x is continuous. Or has a finite number of simple discontinuities. Third one is f of x has finite number of extremum values. What is meant by extremum values? That is finite number of maximum or minimum. These three conditions are known as digitousness. If it satisfies all these conditions, in addition to that, if a naught is equal to 1 by L integral a to a plus 2L f of x into dx, an is equal to 1 by L integral a to a plus 2L f of x into cos n by x by L into dx. Dn is equal to 1 by L integral a to a plus 2L f of x into sin n by x by L into dx. Then the series a naught by 2 plus summation an into cos n by x by L, where the value of n ranges from 1 to infinity, plus summation bn into sin n by x by L, where the value of n ranges from 1 to infinity, is known as trigonometric Fourier series. Trigonometric Fourier series, or else we call this as simply Fourier series. Some persons call this as trigonometric Fourier series since the term involves sine, cosine, and it is developed by Fourier series. Fourier, that is Joseph Fourier. Therefore, they call this as trigonometric Fourier series. Usually, we call this as Fourier series 1. Okay, this is equal to. We may prove that. We can prove that. This series converges to. We can prove that the series f of x converges the terms. What is this? The series, the above mentioned series, converges to f of x. F of x is equal to a naught by 2 plus summation an into cos n by x by L, where the value of n ranges from 1 to infinity, plus summation bn into sin n by x by L, where the value of n ranges from 1 to infinity. We call this series, that is the series mentioned by this formula, as Fourier series. Is it okay? We call that as Fourier series, where the value of a0 and an and bn are defined by this relation. Here, as usual, it has a finite number of simple discontinuities in the interval a plus 2l. The mentioning of that interval is important. Okay. These values, the C0, An and Bn, A0, An and Bn are known as Fourier coefficients. Fourier coefficients. That is, the value evaluated by using these formulas are known as Fourier coefficients. We call this as these formulas, the formulas, expression for A0, An and Bn. These are known as Ayer's formula for Fourier coefficients. Is it okay? Now, I want to find out different forms of Fourier series now. Here, we can able to write the Fourier series for any real value function if it satisfies the three conditions named as Trignometric condition. The first one is it is periodic in that interval. It is the first condition. Second condition is it is continuous or it has finite number of simple discontinuities, means it is removable discontinuities. Third point is it has finite number of maxima and minima. Then we can able to write that function like this, where A0, An and Bn are calculated using that formula. What is that? Here you observe A0 is equal to, I will recall that once again, A to A plus 2l f of x into dx. An is equal to 1 by L integral a to a plus 2l f of x into cos n pi x by L into dx. Pn is equal to 1 by L integral a to a plus 2l f of x into sin n pi x by L into dx. Then, if f of x is a real value function, which satisfies the Dirichlet's condition, and A0 is equal to this much, then f of x is equal to A0 by 2 plus summation An into cos n pi x by L, where the value of n ranges from 1 to infinity, plus summation Bn into sin n pi x by L, where the value of n ranges from 1 to infinity, is the Fourier series. Is the Fourier series of the function f of x. Is the Fourier series of the function f of x in the interval a comma a plus 2l. Is it okay? Now I want to find out some special cases of this Fourier series 0, what happens? If a is equal to minus pi, what happens? If a is equal to L, then what happens? If you know this basic formula, you can evaluate those formulas well using this only. If you first know the things well, you can find out those conditions afterwards. If L is equal to, if A is equal to 0, if A is equal to 0, this is case 1. I will write this. If A is equal to 0, then A plus 2L is equal to what? It is 0 plus 2L, therefore it is equal to 2L. Therefore, A naught is equal to 1 by L integral 0 to 2L f of x into dx. An is equal to 1 by L integral 0 to 2L f of x into cos n by x by L into dx, and Pn is equal to 1 by L integral 0 to 2L f of x into sin n by x by L into dx. And as usual, your f of x is equal to whatever may be the value of a naught, a and bn. We substitute in this formula in order to get the Fourier series. It is a naught by 2 plus summation an into cos n pi x by L, where the value of n ranges from 1 to infinity, plus summation bn into cos n pi x by L. Sorry, here for bn we are writing this as sin n pi x by L, where the value of n ranges from 1 to infinity. This is the formula for the Fourier series. I consider the case 2. Case 2 means here I consider A is equal to minus pi and L is equal to pi. If I consider this case, that is if I am substituting A is in place of A, if I write minus pi, and in place of L, if I write pi, what happens? Your A naught is equal to 1 by L. L means it is 1 by pi integral A to A plus 2L. A is minus pi to pi f of x. A plus 2L means minus pi plus 2 pi. Minus pi plus 2 pi is pi. This is f of x into dx, and An is equal to 1 by pi integral minus pi to pi f of x into, you observe this here in place of L, if I substitute pi, n pi x pi means pi goes with the pi, this is equal to cos nx into dx, and Pn is equal to 1 by pi integral minus pi to pi. Just I am substituting, you observe this, just I am substituting A is equal to minus pi and L is equal to pi in this formula. I am marking special cases ತಗೊಳ್ಳಿಕ್ಕೆ A value 0 ಅಂತ ಇಟ್ಟಿದ್ದೀನಿ, L ನ as it is ಉಳಿಸಿಕೊಂಡ್ರೆ you will get this result. ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀನಿ, ಕೇಸ್ 2 ನಲ್ಲಿ I am substituting A is equal to minus pi and I am substituting L is equal to pi now. Therefore, we can able to write this as f of x into sin n pi x by pi means it is sin nx into dx. Therefore, f of x is equal to a naught by 2 plus summation an into cos nx, where the value of n ranges from 1 to infinity, plus summation bn into sin nx where the value of n ranges from 1 to n. Okay, you observe this. When I am substituting a is equal to minus pi and n is equal to pi, in place of cos n pi x by l, then only cos n x as pi with pi and sin n x. Okay, just I am deducing the result by substituting a value is equal to this much and b value is equal to this much. Here in case 3, I substitute a is equal to l, a is equal to minus l. I am substituting a is equal to minus l. Then a plus 2l is equal to what? I am substituting in place of a minus l. A plus 2l means minus l plus 2l. Therefore, a plus 2l is going to be l only. Okay. Then a naught is equal to 1 by l integral minus l to l f of x into dx, and an is equal to 1 by l integral minus n to l f of x into cos n pi x by l into dx, and Pn is equal to 1 by l into minus n to l f of x into sin n pi x by l into dx, and your f of x is equal to a naught by 2 plus summation an into cos nx plus summation Pn into sin nx, where the value of n, that is the summation, ranges over from 1 to infinity. Is it okay? Here we are finding 3 formulas for this. One is a is equal to 0, and I written that l as it is. In the next place I am substituting a is equal to minus l, and here in this case I am substituting, in the second case I am substituting a is equal to minus pi and l is equal to pi. Okay, here you observe that we can find something new. If I use this fact, if f of x is an even function, we know that cos function is also even. Cos is also an even function. That is, what is that? If I consider this case, cos nx is also even. Then cos f of x into cos nx is even function. Then this, for an even function, if the integral ranges from minus pi to pi, then that integral can be written as 2 times integral 0 to pi f of x into cos nx into dx. Okay. Note, right? In case 2, if f of x is an even function, then f of x into cos nx is also even, and f of x into sin nx is an odd function. You know that result. Even into even will become even and even into odd will become odd function. Then what happens for the value of a0 and a? You observe this, since it is an even function, for any integral in between minus a to a, f of x into dx, you can write that as 2 pi times integral 0 to pi f of x into dx, and an is equal to 2 pi integral 0 to pi f of x into cos nx into dx, and Bn is equal to 0. Bn is equal to 0 means we have to use that property of definite integral. That is, whenever it is an odd function, the integral from minus a to plus a f of x, that is integral minus a to a f of x into dx can be written as, if it is an odd function, you know that it is equal to 0. Therefore, I write this as 0. Okay. No, this is note number 1. Note number E. Or you write this as note number star. If you write this, if you are getting confused with that, if f of x is an odd function, if f of x is an odd function, then f of x into cos nx, is odd. Since cos nx is always even function into odd function will become odd, and f of x into sin nx, that is odd into odd function is even. Therefore, in this case, a0 is equal to 0. a0 is equal to 0 means this is an odd function, integral minus a to a, f of x into dx is equal to 0. We know that property 1, and an is equal to 0 and bn is equal to 2 pi integral 0 to pi f of x into sin nx into dx. You observe this, whenever we can use this technique whenever the limit ranges from minus pi to pi. ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ ಈವನ್ ಫಂಕ್ಷನ್ ಆಗಿದ್ರೆ bn 0 ಆಗುತ್ತೆ. ಈ ತರ ಎಲ್ಲ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಳ್ಳೋದು ತಪ್ಪುತ್ತೆ. f of x ಆಡ್ ಫಂಕ್ಷನ್ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ a0 an ಎರಡನ್ನೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಳ್ಳೋದು ತಪ್ಪುತ್ತೆ. ಓನ್ಲಿ ಯು ಕ್ಯಾನ್ ಏಬಲ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ bn only for that, for a